Hello friends, today I will discuss about different types of IDMT characteristics and how trip time changes with fault current. Before going through this video, you are requested to please go through my channel and do subscribe my channel if not subscribed earlier, and also press bell button for notification of videos to be uploaded in future. Now what does the IDMT means in IDMT characteristics or curve? IDMT means inverse definite minimum time, that is more the current less the trip time. As per IEC, there are basically three types of IDMT curve exist in relay. One is standard inverse, IEC standard inverse. The second one is IEC very inverse, and third one is IEC extremely inverse. One by one I will discuss in this video in details. The three curves, that is IEC standard inverse, IEC very inverse and IEC extremely inverse, can be expressed by the following equation, that is T is equal to T into whole to the power beta by m to the power alpha minus 1 plus L, where T is the operation time of the relay, beta is the constant, and m is the plug setting multiplier or PSM of the relay, that is the ratio of the fault current divided by current setting of the relay. I is the measured current or the fault current, and IS is the current threshold setting or current pickup setting given to the relay, and alpha is the constant, and L is the constant which is 0 for the IEC curve, that is for all the three curves the value of the L is 0, and T is the TMS or time multiplier setting for the IEC curve. Now what are the value of the beta, alpha and L for all the three curves? That is, for standard inverse the value of the beta is 0.14 and value of the alpha constant is 0.02, and as earlier I said, the value of the L constant is 0 for all the three IEC curve. And for very inverse, the value of beta is 13.5 and alpha is equal to 1, and for IEC extremely inverse curve, the value of beta is 80 and value of alpha is 2. Now the first curve is IEC standard inverse. As per IEC standard inverse, the trip time T is given by T equal to T into whole to the power beta divided by m to the power alpha minus 1 plus L. The value of the L constant is equal to 0 and alpha is equal to 0.02 and beta is equal to 0.14. Now consider the value of the plug setting multiplier m equal to 2, that is the ratio of the fault current and to the relay pickup is 2, and TMS, that is time multiplier setting T is equal to 0.1. So the trip time T is equal to 0.1 into 0.14 divided by 2 to the power 0.02 minus 1, which comes as 1 second. That is, at value of 0.1 of TMS and plug setting multiplier of 2, that is double the pickup value of the relay, the trip time comes as 1 second, that is 10 times of the value of the TMS given to the relay. Now again consider that is where PSM is equal to 4, that is higher fault current, that is fault current IF equal to 4 into IS, that is 4 times of the relay pickup, and TMS T is equal to again 0.1. The trip time T is equal to 0.1 into 0.14 divided by 4 to the power 0.02 minus 1, which comes as 0.498 second. Now for different values of PSM, the trip times comes as per the table given in the left side of the picture, and the trip time versus PSM curves is shown in this figure. That is the lower value of the PSM, the trip time will be higher, and for the greater value of the PSM, the trip time will decrease as per this curve. Now as per IEC very inverse, trip time T is equal to T into whole to the power beta divided by m to the power alpha minus 1 plus L. the value of L is equal to 0 and beta is equal to 13.5 and alpha is equal to 1. Now let us consider the PSM value, that is M equal to 2, that is the fault current is 2 times of the relay pickup current, and TMS T equal to 0.1. For these two values, the trip time T equal to 0.1 into 13.5 divided by 2 to the power 1, as alpha is equal to 1 minus 1, that is equal to 1.35 divided by 1, which comes as 1.35 second. But in case of IEC standard inverse, it was 1 second. Now for the higher fault current, that is for the fault current, IF is equal to 4 times of the relay pickup, that is PSM is equal to 4 and TMS is equal to 0.1. What is the value of the trip time? The trip time T is equal to 0.1 into 13.5 divided by 4 to the power 1 minus 1, which comes as 0.45 second. In case of IC standard inverse, it was 0.498 second. So for different values of PSM, the trip time is given by the table as mentioned in the left side of the picture, and the trip time versus PSM curve as mentioned in this picture. It can be clearly shown that the lower the value of the PSM, higher the trip time, and higher the value of the PSM, lower the value of the trip time. Now in case of IC very inverse, the value of the beta constant is equal to 80 and alpha constant is equal to 2 and the L constant is 0. So what is the value of the trip time for PSM equal to 2 and TMS T equal to 0.1? Trip time T is equal to 0.1 into 80 divided by 2 to the power 2 minus 1, which comes as 2.67 second. But in case of IC standard inverse, it was 1 second. So lower the value of the PSM, the trip time is less in case of IEC standard inverse compared to other two curve. Now what is the value of the trip time in case PSM equal to 4 and TMS T equal to 0.1? The trip time T is equal to 0.1 into 80 divided by 4 square minus 1, which comes as 0.533 second. But in case of IC standard inverse, it was 0.498 second. Again, in case of IC standard inverse, the trip time is lower compared to IC very inverse. So for different values of PSM, the trip time is given by the table as mentioned in the left side of the diagram, and the characteristics of trip time versus PSM is given in this diagram. For lower value of PSM, the trip time is more compared to other two graph, but higher value of PSM, the trip time is less compared to other two curve. Among these three types of curves, IEC standard inverse is the most popular one, and it is most commonly used for relays for overcurrent and earth fault setting. So friends, if you like my video, then do subscribe my channel, and thank you for watching my video.